All right, this is a big chapter. It's a big chapter. But we're getting close, getting through it. And we're on slide 37 out of, geez Louise, 60. But now we're going to take a look at expected value and variance for binomial distributions. And remember, we were looking at bivariate and binomial. And bivariate is like variable, bi to variable, right? But instead of variable, we're saying variate. And so bivariate would be used in situations where you have two variables. And a binomial distribution, nomial is like name. And so that makes me think success or failure. We're giving a name to something. And so we saw binomial distribution in the previous video. You could go back and watch that if you want to review. But here we're going to see how to do the expected value and the variance and the standard deviation and for binomial distribution. And we're also going to see an example of that. And so for the expected value, it's this right here. It's n times p, where n, if you remember, is the number of trials, and p is the probability of success on one trial. And so that's the expected value is n, the number of trials, times p, the probability of success on one trial. And to see that in action, Martin Clothing Store, the expected value would be n times p, so three trials, and 0.3 is the probability of success for any one trial. So the expected value, the mean, would be 0.9. And notice the notation for mean is mu. And so I'm keeping track of all this notation here, what the different symbols mean. And so for the mean for a population, the symbol is mu. And if I could see my mouse, I'd be able to show you that. It's like right there. Oh, I could actually draw on that. Isn't that cool? So there's the mean. And the next one we're going to look at is variance. So variance is n times p, and then multiply that by 1 minus p. And so here it's 3 times 0.3 times 1 minus 0.3, and that gives us 0.63. That's how you calculate the variance for binomial distribution. And then standard deviation is the square root of that. So you take the square root of 0.63, and we get 0.79. So there's your standard deviation. And so they're using sigma here, lowercase sigma, for the notation for standard deviation. So I imagine it'd be okay to use let me see my mouse, it's right here. Use that for variance if you wanted to, because that's the notation, though they don't put it here. Those kinds of inconsistencies in the textbook kind of make me scratch my head, but that's the way they're doing it. All right, so that's how you calculate the expected value and variance for binomial distribution.